morning friends. In chapter 11 we discuss about the MCQ question important for unit test and internal test. Already we discussed the MCQ question asked in JEE, NEET and also the good set and also board exam. Right? For the extra practice we are considering the other MCQ question. Right? Some of these already we calculate in JEE and NEET. Now already we discussed the 6 MCQ question and we get the practice about that. Now the other questions are, some depends on the theoretical concept and some depends on the what are the equation already we learned in theory portion. Now the next question is that if the velocity of an electron increases, then its de Broglie wavelength. What about the change take place in the de Broglie wavelength of an electron if its velocity increases? Already we discussed about the equation of the de Broglie wavelength relate with the particle nature and wave nature. Lambda is equal to h upon m. Right? Therefore, the de Broglie wavelength lambda is equal to h upon mv. Here the h and m are constant. H is the Planck's constant, m is the mass of the particle constant. Therefore, lambda proportional to the 1 upon v. But the de Broglie wavelength is inversely proportional to the velocity of the particle. Now, the velocity of an electron increases as the v increases, lambda decreases. V increase if V increase, lambda decrease. Therefore, answer is wavelength, de Broglie wavelength of an electron is decreased if the velocity of an electron increases. According to this equation, lambda is equal to h upon m. Clear? Now, E and P be the energy and momentum of the photon. If the lambda decreases, then what we change take place in total energy and momentum of a photon. Again, here the question is that E and P be the energy and momentum of a photon. If the wavelength of photon decreases, then what's happened? P and E both decreases. Next option, P and E both increases. Either P increase, E decrease, or P decrease, E increase. Right? So what we say there? First, for the photon, energy of photon, E is equal to, energy of the photon is E, P is equal to E upon C. Or the E is equal to P into C. That means the momentum into velocity of light. Now E is equal to hf upon C. hf upon C. Now F upon C is equal to 1 upon lambda, because we know that the C is equal to F lambda. Therefore F upon C is equal to 1 upon lambda. Therefore, h upon lambda. But the lambda is equal to h upon p. Right? So thus we obtain the equation. Equation shows the relation between the momentum and wavelength, energy and wavelength. So here P and E both inversely proportional to the wavelength, and energy E is also inversely proportional to the wavelength. As lambda decreases, so what's happened? P and E both increases. Both increases. Again, the P proportional to the 1 upon lambda and E proportional to also 1 upon lambda from this relation. Because the energy of the photon E is equal to momentum into C. Right? But the momentum P is equal to E upon C. So we write like this way, note energy, momentum of photon. Momentum of photon P is equal to E upon C. Therefore, E is equal to hf upon C is equal to h upon lambda. Right? Using this concept, the P proportional to the 1 upon lambda and E is also proportional to the 1 upon lambda because the h and c are the constant. Therefore, as the lambda decreases, so both P and E increases. Clear this? So very easy. After that, the next question, that is the frequently asked in board exam. Which of the following quantity has the same dimension of the Planck's constant? So for the answer of this question, we must be familiar with that. What is the dimension or what is the SI unit of Planck's constant? What is the SI unit of Planck's constant? So SI unit of H is joule into second. Joule into second. Clear? Okay. Now, energy has the unit is joule. Work is also joule. Force has the Newton. Therefore, the remaining quantity is the angular momentum. What is the equation of angular momentum? Angular momentum is mvr. mvr. And also, according to the Bohr's first hypothesis, the angular momentum of an electron in nth orbit is mvr is equal to nh upon 2 pi. nh upon 2 pi. N represents the number of orbit, 2 pi is the constant. Therefore, h is the Planck's constant is equal to angular momentum. Therefore, the dimension of the Planck constant is same as the dimension of angular momentum. Clear it? One of our concept is that we know the SI unit of energy is joule, but it also joule, force is Newton. So this three quantity has the no SI unit is joule into second. The remaining quantity is the angular momentum should have the dimension of Planck's constant. Or in other words, from a theoretical concept, from the Bohr's first hypothesis, the angular momentum of an electron in nth orbit is integral multiple of h upon 2 pi. Therefore, angular momentum mvr is equal to nh upon 2 pi. N is the number of orbit, unitless, 2 pi is the radian, right? That is the dimensionless. Therefore, the dimension of angular momentum is same as the dimension of Planck's constant. Therefore, the angular momentum is the physical quantity which has the same dimension of Planck's constant. Clear? Okay. Now next is, yeah, I can write like this way. mvr is equal to nh upon 2 pi for your information. Now next, the de Broglie wavelength of an electron having the energy is 10 kilo electron volt is. The de Broglie wavelength of an electron having the energy 10 kilo volt is how much angstrom? So we have to find out the de Broglie wavelength of an electron having the energy is given the 10 kilo electron volt. E is given 10 kilo electron volt. So 10 kilo into 10 is to 3. Electron volt convert into the joule, 1.6 into 10 is to minus 19. So 1.6 into 10 is to 19 here 4, 10 is to minus 15 joule. That is the energy. Now we require the de Broglie wavelength corresponding to the energy. Therefore, what is the equation? Lambda is equal to h upon under root of 2m. The de Broglie wavelength of an electron having the energy is E is lambda is equal to h upon under root of 2 me. Substitute the value of all quantities. Planck's constant 6.625 10 is to minus 34 divided by under root of 2 m mass of an electron 9.1 10 is to minus 31. Energy just we obtained 1.6 10 is to minus 50. So as we calculate it, we obtain the energy is 0.12 angstrom. 0.12 angstrom. That is the wavelength of an electron having the energy is 10 kilo electron volt. So generally the one question is asked on the depends on the energy or the potential difference and also the temperature 3 mkBT. The three equations of the wavelength, de Broglie wavelength, one relate with the energy, lambda is equal to h upon under root of 2 me. Second, relate with the temperature, just we discussed in earlier numerical, lambda is equal to h upon under root of 3 mkBT. Another equation, lambda is equal to h upon under root of 3 mkBT. And one more equation of the wavelength relate with the potential difference. So lambda is equal to h upon under root of 2 MeV. So these three equations are most important. On the base of these three equations, generally the one question 100% asked in any exam. One is on the base of the energy, second on the base of the temperature, and third is on the base of the potential difference. So here the de Broglie wavelength of an electron having the energy is 10 kilo electron volt is 0.12 angstrom. Clear? So using this concept, lambda is equal to h upon under root of 2 me. H is the Planck's constant upon 2 m. Mass of an electron is the energy of this electron, 10 kilo electron volt. Now next, to obtain the momentum of an electron same as the momentum of photon having the wavelength 5200 angstrom, the velocity of an electron is how much required? So here we require the momentum of an electron is same as the momentum of photon. Having the wavelength lambda is equal to 5200 angstrom is equal to 5200 into 10 is to minus 10 meter. So what should be the velocity of the electron required? Mass of the electron is 9.1 into 10 is to minus 31. We require the velocity. Now here the de Broglie wavelength also same, lambda p is equal to lambda alpha. So we require the momentum, therefore P is equal to M. P is equal to that. Now directly the P is not given, so we can write the P is equal to h upon lambda. Right? Momentum is equal to h upon lambda. Therefore velocity V is equal to h upon m lambda. H upon m lambda. Substitute the value, Planck's constant 6.625 10 is to minus 34 upon mass of an electron 9.1 into 10 is to minus 31 into wavelength 5200 into 10 is to minus 10. So we can calculate the velocity is 1.4 into 10 is to 3 meter per second. That much velocity of the electron is required to get the same momentum of a photon having the wavelength is 5200 angstrom. Again, how much velocity of an electron is required to obtain the momentum is same as the momentum of photon having the wavelength is 5200 angstrom. So we know that the momentum P is equal to mv, and momentum in terms of the wavelength is P is equal to h upon lambda. Therefore mv is equal to h upon lambda. We require the velocity, therefore v is equal to h upon m lambda. Substitute the value of Planck's constant, mass of an electron, lambda is the wavelength. Thus we obtain the value of speed or the velocity is 1.4 into 10 is to 3 meter per second. So that much speed of an electron is required to obtain the momentum of an electron is same as the momentum of photon having the wavelength is 5200 angstrom. Clear? So very easy. After that, the next class. The de Broglie wavelength of photon and alpha particle are same. Then the ratio of their velocities is. Now the alpha particle is the helium nucleus, right? Okay. 2He4. Therefore, the mass of the alpha particle is 4 times then the mass of the proton. Mass of the proton. And the charge of the alpha particle is double than the proton. But here the charge is not required. Only the mass is required. Again, the de Broglie wavelength of proton and alpha particle are same. Therefore, lambda of proton is same as the lambda of alpha particle. Now we know that de Broglie wavelength lambda is equal to m upon v. So h upon mv. Therefore, h upon mass of the proton, velocity of the proton is equal to h upon mass of the alpha particle, velocity of the alpha particle. We require the ratio of velocity of proton to the velocity of alpha particle is equal to m alpha upon mp. But here m alpha is 4 times the mass of the proton. Mass of the alpha particle is 4 times the mass of proton. Therefore, velocity, ratio of the velocity of proton to the alpha particle is equal to 4 times mp upon mp. Mass of the proton cancel, therefore 4 by 1. Therefore, this ratio is 4:1. 4:1. Again, the de Broglie wavelength of proton and alpha particle are same. Then the ratio of their velocities. That means we have to find out the ratio of velocity of the proton to the velocity of alpha particle. Here, de Broglie wavelength are given same for proton and alpha particle. Equation of the de Broglie wavelength lambda is equal to h upon momentum or the h upon mp. Therefore, for proton, h upon mp vp. For alpha particle, h upon m alpha v alpha. H is cancelled. Therefore, vp upon v alpha is equal to m alpha upon mp. Here the mass of the alpha particle is given, that is the 4 times the mass of the proton. Therefore, m alpha is equal to 4 mp, substitute here. Therefore, 4 mp upon mp, mp cancel. Therefore, 4 by 1 or the 4:1. Clear? Now next, an electron is accelerated by how much potential difference? So its de Broglie wavelength becomes the 0.4 angstrom. Here the de Broglie wavelength is given lambda is equal to 0.4 angstrom. That means 0.4 into 10⁻⁻10 meter. So with whatever the potential difference, the electron must be accelerated. So its de Broglie wavelength becomes this. So here relation between the de Broglie wavelength with potential difference. Just we discuss or write down the three equations of de Broglie wavelength. One is depends on energy, second related with the temperature, and third is related with the potential difference. So we know that the lambda is equal to de Broglie wavelength is equal to h upon under root of 2 MeV. We require the potential difference making the square. Therefore, lambda square is equal to h square upon 2 Me. Therefore, V is equal to h square upon 2 Me lambda square. 2 Me lambda square. Substitute the value. H Planck's constant 6.625 to 10⁻⁻34 upon 2. Mass of an electron 9.1 into 10⁻⁻31. E charge of an electron 1.6 into 10⁻⁻19. Lambda 0.4 into 10⁻⁻10. We obtain the value is 941.01. If the electron is accelerated by this voltage, so its de Broglie wavelength becomes 0.4 angstrom. Clear it? So very easy MCQ question. And to solve this MCQ question, first our concept about the equation already we learned in theory must be clear. First read the question carefully and think what are the data are given and what we need to find out. Right? So at that time we can solve any MCQ type question.